So here we'll take a look at a few square root graphs that have some transformations being applied to the parent function square root of x. I'm going to start off by drawing in the parent function. So remember, it starts at the origin, and then we have that numerical pattern. Over 1, up 1, over 4, up 2, over 9, up 3. So that's what the graph looks like with no transformations. But in this case, we do have some changes. So to start off with, we have this plus 4 on the back end. So anytime we have something added or subtracted, either inside or outside of the function, that's going to cause a translation. The graph is just going to slide either horizontally or vertically. And because of the plus 4 that's on the outside, that means our graph is going to move in the vertical direction. So we're going to be translated up 4 units. So now, instead of our graph starting at the origin, we know that our graph is going to start off up 1, 2, 3, 4, right there. If that was the only change, then we would just recreate the exact same graph as we see there in black. But we also have a second change, which is this 3 that's multiplying the square root of x. So that causes a dilation in the vertical direction. So we have a dilation by a factor of 3 in y. So the graph is being stretched in the vertical direction by a factor of 3, meaning that all of our ups in our numerical pattern, instead of going over 1, up 1, we're now from this new starting point here, we're going to go over 1, up 3 times as much, so up 3. Instead of going over 4 and up 2 like we do on the parent graph, we're going to be over 4 and up 3 times 2, so we're going to be up 6 from that same height. So that's going to put me right about there. Over 9 up 3 becomes over 9 up 9. And so you can see that we're going off of the graph pretty quickly here, so it's going to be a graph that looks like this. You can see that this graph is going up much faster than our parent graph because of that multiplier by 3, and it's starting from this new location here 4 units up because of the translation of going up by plus 4. We have no reflections. There's no negative sign multiplying on the outside or multiplying the x on the inside, so we don't have anything like that. And then we should also identify what the domain and then also the range of this function are. So domain is just a question of what x values does the graph include. So by just looking at it, we can see that the graph starts from the y-axis, which is where x equals 0, and then it's everything to the right from there. So we can say that our domain is x is greater than or equal to, let's try to fix that a little bit, greater than or equal to 0. The other way we can get the domain is how we did it previously, where we take whatever is underneath the radical symbol and just set it greater than or equal to 0. In this case, there's no solving to do, so there's our domain. And then the range we can only get by looking at the graph. And so the range is a question of what y values does the graph include. So this graph is starting from a height right here of y equals 4, and then it's just always going up from there. So even though the rate is slowing down, it's always still going to be creeping up. So we can describe the range, the y values this graph includes, as being y is greater than or equal to whatever that lowest point is, which in this case is 4. So for the next one, we can see that we have a plus 5 underneath the square root symbol. We have a minus 8 on the outside. So since our only changes are addition and subtraction based, that means we're only going to have a couple of translations. We're not going to have any dilations. There's no number multiplying on the outside of the square root symbol, nor a number multiplying the x. And then we have no reflections. There are no negative signs on the outside of the square root function or in front of the x on the inside. So we just have 2 translations. Now because of the plus 5 on the inside of the square root symbol, we're going to move in the horizontal direction, and with horizontal translations, those are in the opposite direction of the positive negative sign that we would expect. So with a plus 5 on the inside, that means we're going to be translated left 5 units, and for the -8 on the outside, that's going to be a vertical translation, which, like in the previous example, goes in the direction that we would expect. So -8 we associate with being down, so we're going to say down 8 units. So those are our only two transformations. So that means instead of my graph starting at the origin, like this parent graph that we sketched earlier does, we're going to go to the left 5, and then we're going to go down 8. So we're going to start right about here. And so from there, our usual pattern of the parent graph of over 1, up 1, over 4, up 2, over 9, up 3 is going to hold up. And so there's the sketch of our graph. So it has the exact same shape as our parent graph. It's just been translated to the left 5 and down 8. For the domain, again, we could just look at the graph and identify what x values it includes, or we can take the part that's underneath the square root symbol and set it greater than or equal to 0 and come up with the domain that way. So if I subtract 5 from both sides, we get x is greater than or equal to -5. So there's our domain. And then for the range, we're just going to need to figure that out by looking at the graph. So the lowest y value that the graph hits is -8. The graph only goes up from there. So that means our range is going to be y is greater than or equal to -8. In our next example, we see 3 transformations. It looks like it's just 2, but we should treat this negative sign, the 2, and then the -1 all separately. So the negative sign that's out front causes a reflection. So we have a reflection in the x-axis. So what this means is, instead of our graph having a shape where it's going up like this, it's going to be going down instead. So instead of going over 1, up 1, if that was the only change, we'd go over 1, down 1, over 4, down 2, over 9, down 3. So the graph is going to be going down instead of up because of that negative sign. Because of the 2, that's another dilation. So we're dilated by a factor of 2 in the y direction. So meaning all of our vertical movements are going to be twice as big. And then finally we have the translation because of the -1. That's underneath the square root symbol, so it's going to be horizontal and in the opposite of the direction that we would expect. So we're going to be translated to the right 1 unit. So that is going to affect our starting point. So we're going to go to the right 1 unit, and that's where our graph is going to start. And then from there, we're going to go to the right 1, but then we're going to go down instead of up because of the reflection, and we're going to go down 2 instead of just 1 unit because of the dilation. So we're to the right 1, down 2, we're going to go to the right 4 from that starting point, and then instead of down 2, we're going to go down twice as far because of the dilation. So that's going to put us right about there. And then we're going to go to the right 9 and down instead of 3, twice as far, we're going to go down 6. So that puts us right about there. So we end up with a graph that looks like this. So again, going down because of the negative out front instead of up, that's the reflection. Dilated by a factor of 2, so we're going down 2, going down 4, going down 6, instead of going down 1, 2, and 3 units. And then we were translated to the right 1 unit. For the domain, we can see that this graph starts here in the vertical direction at x equals 1. So therefore our domain is x is greater than or equal to 1. And then for the range, we're starting from the x-axis where y equals 0, and then we're just going down from there. So our range, the y values this graph includes, are going to be y is less than or equal to 0. For the last one of the bunch that we have here, we have a negative sign on the outside, a negative sign on the inside, and then this +3 on the outside. So starting with that first negative sign, so we've seen that before, that's going to be a reflection in the x-axis. So that by itself, instead of going up like this, we would end up going down, just like on the previous example. But then we also have a negative sign on the inside of the square root in front of the variable. So that's going to cause a reflection in the y-axis as well. So that means instead of going to the right, the graph is going to be going down and to the left. So the general shape that we're looking at is going to be the one that's in the circle here. So we kind of have a double reflection, going down instead of up, going left instead of right. And then finally, we have the translation because of the +3. That's on the outside, so it's in the vertical direction, and it's going to be up 3 units. So we're translated up 3 units. We have no dilation. There's no number multiplying the x or multiplying the square root on the outside, so we got nothing like that. So now we're ready for our graph. So instead of starting at the origin, we're up 3 units because of the translation. And then, like we said, because of the 2 reflections, instead of going over to the right and up, we're going to be going over to the left and down. So I'm going to go to the left 1, down 1. I'm going to go to the left 4, down 2. And I'm going to go to the left 9, down 3. And so we, generally speaking, end up with a graph that looks like this. For the domain, so again, that's a question of the x values. So we can either just look at the graph, or I can take whatever is underneath the square root symbol and set it greater than or equal to 0. So if I want to solve, we think of this as being -1 times x. So I divide both sides by -1. And so we get x is less than or equal to 0, since if I divide both sides of an inequality by a negative, I have to flip the inequality symbol. So my domain is x is less than or equal to 0, which is what my graph shows. X equals 0 right here at the x-axis, and we're going to the left. And then for the range, what y values does the graph include? Well, the graph starts here at y equals 3, but then it goes down from there, but it keeps on going down forever. So if we're going to describe those y values, it's going to be y is less than or equal to 3.